Okay, now that you've checked out the unit circle video, you've been saying, you're probably thinking to yourself, wait a minute, now we talked about trigonometry, we're in all this trigonometry stuff, and we're saying, well, that's all triangles. We know about trigonometry with triangles. Let me show you where that triangle stuff comes in. If you remember, we put the unit circle on a coordinate plane. We know the coordinates of this point are 1, 0. We know the coordinates of this point are 0, 1. We know the coordinates of this point are -1, 0. And we know the coordinates of this point down here are -1, sorry, other way around, 0, -1. Okay? And since we know all of those things, okay, now we could find any point on the edge of this circle. Right here, we could find any point on the edge of that circle. Now, if we want to relate that circle, we know that it has to fit in the equation x squared plus y squared equals 1, because that's the equation of the unit circle, and it's a point on there. So you can do that. But what if we wanted to relate? Well, let's just draw that again real quick. Let's see, x squared plus y squared has to equal 1. Okay. So let's just draw that x squared and that y squared. So let's see, the x squared, so the x coordinate of this point, x comma y, well, that's not a very good marker. This black's going to be our beauty here. X comma y, ooh, that blue really doesn't erase well. X, y. Okay, if we go this xy here, then that means that to get to this point, I have to travel out x units. And then as soon as I get directly below the point, I have to travel up y units. And I know that the radius of the circle is 1. So I know that's 1. So that's where we get our x squared plus y squared equals 1. Again, from that Pythagorean theorem and the connection between those two things. All right, so, but I want to relate now our angles into this. Trigonometry relates the angles of the triangle, or an angle of the triangle, to the two legs of the triangle. So let's see. Let's say that I have a triangle. Let's come up with one that we actually know. If that's one, let's see. If that's one, then let's say this is a 60-degree angle. Let's say that's a 60-degree angle right there. So now I picked 60-degree angle because I know that that's a special right triangle, and then I know that the hypotenuse, the shorter leg is 1/2 the hypotenuse, and the longer leg is the shorter leg times the square root of 3. So let's see, square root of 3 times 1/2, that's going to be square root of 3 over 2. Okay, so now I can say, well, I know what these coordinates are. On a 60-degree angle, I know what these coordinates are. Let's see, this is 1/2, and this is square root of 3 over 2. All right, good. Okay, so now I know that if I take my pen, if I take my spinner, and I rotate 60 degrees, I'm going to get to the coordinates of the point 1/2 comma square root of 3 over 2. Okay, so if you think about, well, wait a minute, the sine, if we remember back to our old days, it's still trigonometry. We haven't said anything about trig yet. We haven't had sine, cosine, tangent. We haven't said anything about that yet. So let's see. Let's actually do that. Well, what's the sine? This is a right triangle, right? What's the sine of that 60-degree angle? Well, the sine of that 60-degree angle is the opposite over the hypotenuse. And the opposite angle, okay, the opposite side is the y coordinate, which is square root of 3 over 2. And the hypotenuse is 1. It's the radius of the circle. So square root of 3 over 2. So in that situation, now we have the sine. So now you got that kind of sine stuff built in there. Oh, trash guys come. Okay. So let me get rid of some of this stuff. But wait a minute. What if my triangle's not in that quadrant? Okay. What if I rotate past that? Let's see. Let's think real quick. How far would I have to rotate into quadrant 2 before I get an identical triangle there? Well, let's see. I want to go out. I want an identical triangle. So I want to go out a half, and I want to go up square root of 3 over 2, and I know the hypotenuse is going to be 1. So what are the coordinates of this point? The coordinates of this point are -1/2 and square root of 3 over 2. Okay, right there. They make a right triangle. It makes the identical right triangle. Now, what do I know? If I have this situation, 1/2 square root of 3 over 2, what's the angle that makes that ratio? Oh, it's 60. 60 degrees. So I know that angle in the middle is 60 degrees. So if that angle in the middle is 60 degrees, what was the angle of rotation to get to that point? Well, oh gosh, I don't know. There's lots of ways to figure this out, but my favorite way to figure this out is to just figure out how far away you are from the nearest x-axis. How far are we from that nearest x-axis? From here, from this spot. Because this, I know this is 60 from that x-axis right there. So let's see, this angle and this angle have to make up 180. So I didn't quite get to the 180 spot. I stopped 60 degrees before that. So that is 120 degrees. So right now, we know that 60 degrees makes a triangle that we know about. It makes this triangle, 1/2 out, square root of 3 over 2 and 1 in the first quadrant, Q1. And then 120 degrees makes our triangle in quadrant 2. So this is right here 60, and this is 1/2, and this is square root of 3 over 2, and this is 1. And that's our quadrant 2 triangle. Well, you know what I'm going to ask now. What about quadrant 3? What if we get to quadrant 3? How far do we have to rotate to make that same triangle, to make this same 60-degree triangle, where we have square root of 3 over 2 and 1/2 and 1 in this quadrant? Let's see, that would be -1/2 negative square root of 3 over 2. How far do we need to rotate? Well, we know that if I want this ratio, if I want that triangle to be the same, I know I need 60 degrees there. So if I think again of our rotation, I got to 180 here. If I started here and I got to 180, is that far enough to get to this spot, to get my spinner to there? Let's see, this is 180. How much further do I have to go? Well, I know that angle's 60, so I'm going to go 60 more. So if I add 60 plus 180, that's 240. Hey, 240 is the one that gives us, oops, draw that right, Mr. Hunt. Oh, there you go. Okay, let's see. That's the one that draws this triangle going out a half and down square root of 3 over 2. And this is my 60-degree angles there. And this is the 1/2, and this is square root of 3 over 2. And this is 1, and that's my quadrant 3 right there. And then what, obviously here, I'm just going to see if you can figure out what's the rotation that's going to get me to here, to get this triangle, this quadrant here. Okay, where we've got 1/2 out and square root of 3 over 2 that way. Yeah, you're right. It's 360. Sorry, 300. Okay, 300 degrees gives us this triangle where it's 1/2 out and square root of 3 over 2 down. And this coordinate down here, this is going to be 1/2 and square root of 3 over 2. So what we say, what I call this is, I call this a family of angles. This is quadrant 4. Okay, this family of angles all make exactly the same triangle. All these make exactly the same triangle. They just make them in different quadrants. So the quadrant 1, okay, the quadrant 1 family member is 60 degrees. The quadrant 2 family member is 120 degrees, and the quadrant 3 family member is 240 degrees, and the quadrant 4 is 300 degrees. So those are all 60 degrees away from the nearest x-axis. So they all make the same triangle because they're 60 degrees from the x-axis. Now I'm just going to say one thing. Some students will get screwed up and they'll do it from the y-axis. Never do it from the y-axis. We have, it would work if we define trig a different way and where standard position was and everything, but it just muddies the water a lot. So just worry about how far is your angle? How far did your spinner stop from the nearest x-axis? All right, so this quadrant 1 family member right here, quadrant 1 family member, kind of the head of the household right here. This quadrant 1 family member is called the reference angle. That's called the reference angle. Okay, so the reference angle is kind of you think about that. I think even in trig, you guys have used the reference angle idea before. In geometry, where it's the reference angle, it's the one that you're looking at. Okay, so there's a reference angle. So let's talk about some families. Let's see if we can get this kind of done here. Well, I'm going to do this. Okay, erase all this stuff. Again, kind of freezes on. It's not quite summer, is it? Well, just because you'll get a kick out of it. So adapt and overcome, right? So right now, because my markers were freezing, I put them in this crock pot in there. There we go. So now I got markers in the crock pot to keep it warm. And now I have just learned, I've got an idea here, because the board's freezing it. There. Ooh, shoot. Let's see. I just put my eraser spray in there too, and let's see if that works a little bit better. Adapt and overcome, right? Okay, so referencing. Well, I got to grab a marker again. Okay. So here's my question. Okay, I want to know what the reference angle is for 200 degrees. What is the reference angle for 200 degrees? Question mark. Okay, so what's the reference angle for 200 degrees? Well, first of all, I have to draw where it is. Okay, I have to draw where it is. And in my unit circle, 200 degrees lives right there. And we know that the triangle that it makes right here, this right triangle that it makes, I'm not asking for what these two X and Y's are. There is some X and there's some Y that we know, okay? Or that we could find. That's not what I'm asking for here though. I'm just asking, what is the reference angle? I want to know who is the head of this family? Who's the head of this family of angles? So this family of angles, you know, here, here, and here, okay? And if I would have drawn that unit circle better, but this is the same in every spot, this angle right here, theta, I'm gonna call it 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 theta. That angle right there that it makes, that's gonna be the same for every family member. So let's see, this is 180 degrees. If I get my spinner all the way to here, always think about that spinner, right there, that's 180 degrees. I've gone 180 degrees and I have to go theta more, right there. So let's see, what is that angle? So I got to get to 200. I know that I'm all the way to 200. Well, the first 180 get me to here, boom. So I only got to go 20 more. So that theta angle is 20. So the reference angle is 20 degrees. So the family of angles, let's just go through the family. So the family has a quadrant 1 member, a quadrant 2 member, a quadrant 3 member, and a quadrant 4 member. Quadrant 1 member is 20 degrees. The quadrant 3 member was 200 degrees. What was the quadrant 2 member? Well, let's see. 180, but I'm not quite to 180. I'm 20 degrees behind 180 or before or short of 180. So that's going to be 180 minus 20, so it's 160. I've gone to 180 and I come back 20. That's how I think about it. Here I think about I go to 360 and I come back 20. So that's going to be 340 degrees. You always have to think about this spinner. Get that spinner going in your head, and that'll help you out a lot. All right, so that was nice to introduce that reference angle. I hope that you kind of got the reference angle idea from that. We're going to be using reference angles. Oh, let's see if this works. Let's see if my heated up spray like a charm. Okay, So let's grab a marker again. So now let's play the game with radians. Okay, and radians, again, we're going to have to look at those denominators being the same. So, okay, here's my unit circle again. Okay, and I want to know, find the reference angle for 5 pi over 4 radians. 5 pi over 4 radians. That's what I want to find. Find a reference angle there. Okay, so let's figure this out. Maybe you're already ahead of me here. I'm just getting a marker out. Okay, 5 pi over 4. Well, remember, this is 0, so I can kind of get this oriented. That's 0 radians. This is pi radians. This is halfway there, so that's pi over 2 radians. And this is 3 pi over 2 radians. So I really got to think about, what are we going to call those spots? What do we have to call those spots? We have to call, let's see, I want it over 4. So this isn't going to be pi, it's going to be 4 pi over 4. That's the same thing, 4 pi over 4. And how about down here? This is going to be, I say I need that to turn into a 4, so multiply by 2 over 2. That's 6 pi over 4. This spot over here is 8 pi over 4. How did I know that? Well, that was what 2 pi was. And then this is going to be multiply 2 over 2, 2 pi over 4. So again, so our fraction stuff kind of helps us here. Okay, so that's 2 pi over 4. So now we're going to go into how this all works. Let me just, okay. So let's see, 5 pi over 4. Where's 5 pi over 4 terminate? I got to figure out where it terminates first. 5 pi over 4 terminates right there. Okay, how do I know that? It terminates somewhere between 4 pi over 4 and 6 pi over 4. I don't really care. Did I draw it right? It's probably not quite right in the middle, but it should be. Okay, so now what is this right here? Well, this is, let's see, this is 4 pi over 4. I know this is 5 pi over 4. So what do I have to add to 4 pi over 4 to get to 5 pi over 4? How much further past do I have to add? Well, I'm at 4 pi over 4. I have to add another to 5 pi over 4. So I'm thinking in my head, 4 pi over 4 plus what is 5 pi over 4? So if you're used to counting by fractions, you're in good shape. So let's see. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Oh, I just add pi over 4. 1 pi over 4 is what gets me to that. So I had to know what quadrant I was in so I could draw the picture. I had to think about that spinner, but now I'm at 5 pi over 4. So the reference angle is equal to pi over 4. So again, I wonder what the family is. Not asked in this quadrant, but let's just figure out the family. Quadrant 1 member was pi over 4. Quadrant 2 member, Quadrant 2 family member would live here, right? So let's see, I'm not quite to 4 pi over 4. I know that the gap now is pi over 4. I know that the reference angle is pi over 4. So if I'm at 4 pi over 4 and I come back 1 pi over 4, I'm at 3 pi over 4. And then quadrant 3, let's see, quadrant 3 we already knew, that was 5 pi over 4. And quadrant 4, so I don't want to go all the way. I go all the way to 8 pi over 4, but then my quadrant 4 angle lives right there. That's pi over 4. We know that that's the reference angle. So now I come back pi over 4, and I get to 7 pi over 4. And there's our family. There's our family for those angles again. All right, so there's our reference angles and our family's angles on the unit circle in both radians and in degrees. Hope that helped.